also is very interesting. I am involved in the field of consciousness by Federico Fagin, that I met the first time in Vieques Island, Puerto Rico, for the fourth FQXI meeting, and more than 8 years ago. We started regularly to discuss about information theory, quantum theory, and classical theory, along with the problem of consciousness. And I was quite skeptical at the time, but I got fascinated. And later I decided that making new science is simply to derive logically the consequence of reasonable shared assumptions, and in such sense also the study of awareness, or consciousness as you like to call it, is science at the preliminary stage. What I'm going to present today to you is an information theoretical approach that seems well suited to me to the problem of consciousness, as you will judge yourself, and which, with some reasonable assumption that in my knowledge are shared by many other scientists, lead to some interesting consequences. The information approach, as any other probabilistic theory approach, so-called operational probabilistic theory approach, OPT, is well defined, is well suited to the problem, since it is independent on the physical implementation, including the physiological one. And this is really great merit of the OPTs. On the other hand, we can propose cognitive tests and to check the theory also, in principle, as you will see. Let's see if it works. I have to change transparency. Yes. In our theory derivation, I follow some very precise and reasonable dictate of David Chalmers, who spent a lot of time on the problem of how the theory of awareness should be, in two thick books that I transversely read, which well define for the first time what is what everybody call the hard problem. Now called the hard problem. This was a term invented by him. And so he says, what is the performance of these functions accompanied by experience? So a reductive explanation would fail by definition, he says, because the experience has nothing to do with functioning. A simple explanation of the function leaves the question open. And why doesn't all of this information processing go on in the dark, free of any inner feeling? Why we should feel it? Why we feel it? There is an explanation gap between the function and the experience. These are completely separate things. Non-reductive explanation is required. Consciousness as a fundamental entity, not explained in terms of anything simpler. Again, David Chalmers says, in particular, a non-reductive theory of experience will specify basic principles that tell us how basic experience depends on physical features of the world. These psychophysical principles will not interfere with physical laws, closure of physics. So rather, they will be a supplement to physical theory. So essentially, we should derive some new principle that has to do with physics, but does not change the physics. This is the idea, and I completely share his point of view. So as we will see, this new approach is a black box approach. Namely, we don't know what is the system that supports the information, what is the physical implementation of the theory. We have too little knowledge of physiology to address the problem in a detailed theory. And knowledge of the functioning is of no help in solving the two main problems, hard problem and free will. What then can be done without a bottom-up functioning approach? So the method is the usual method of science: make plausible assumptions, build up conceptual framework, establish general principles, derive their consequences, and design a prototype theoretical scheme, and possibly suggest experiments. So information is everywhere, is ubiquitous. Light comes through our eyes, providing us with the content of space around us, and gets the nerve, the optical nerve, and up to the brain, whatever, to something that is the residence of our consciousness. So what is awareness? Consciousness or awareness, I use them as synonymous, even though they are a little bit different, is the direct experience of the end. Is the direct experience of the end of the information chain that comes to us. It is the feeling of the information processing. This is the main general hypothesis. So consciousness is the feeling of the processing of information. So consciousness is the most direct fruition of a very structured kind of information, manifesting through different types of qualia: color, sound, taste, smells, touches, somatosensation, pain, pleasure, sadness, happiness. These are all different kinds of qualia. And we are the system that supports such final information. So we are the system for this information. What is a system? We will see now soon. It is an operational probabilistic theory ingredient, is what supports states, like, for example, a bit or a qubit, is a featureless support of states. So our starting point is what we think is self-evident, is awareness is a kind of information, right? So here I will depict with different colors self-evident assertions, hypotheses, heuristic. So I cannot see even what heuristics, theoretical, experimental. And so what is self-evident for us for now is that awareness is a kind of information. I hear my voice back after a few minutes, few seconds. I think there is a feedback.
Oh, you're hearing feedback?
A lot of the speakers are saying
Sometimes I see I listen to my voice 10th of a second after.
Yeah, it could be.
It's very.
It could be someone who mute. Like you have to sort of mute your Zoom and your audio on your laptop, but I can also just mute things here.
Okay. Now I don't listen to anything. It's okay. So awareness is the feeling of the information processing. This is the main starting point. So is being the system supporting information. A system has states, and the states make the information that it supports. So you are essentially a system supporting information. So what is a system? Is an operational probabilistic theory notion. So the OPT is a general black box approach in which you connect events like can you see my arrow on the screen? Sorry, I hope so. And you connect events that occur with some probability by systems that connects the events in a way that the probability of each event depends on what is connected to the input, and more generally also for some theories what is connected to the output. And And a full collection of all possible events in one point is what we call a test. And so note that the marginal depends on the marginalized part of the graph. So all these events depend on the events happening in the same connected part. But generally, if there are two disconnected parts, like in this case, this one and this one, the probability factorized. So the probability in each connected graph depends on the graph connections, and if there is a separation of pieces of the network, then the probability becomes a product of probability. So the operational probabilistic theory is a very general approach, or I could say is almost a paradigm of the scientific method. So you connect objective things happening that we call events, devise a theory of such connections that you call systems. So the theory, systems are theoretical notion, events are the objective part, and make prediction for future occurrence, predict joint probabilities of events depending on their connections. So this is a very general approach for science. And which events happen is objective, whereas systems are theoretical. So you don't see the particle in a Stern-Gerlach apparatus going from one side to the other. The particle is a theoretical notion. This actually would be the point of view of, of Bohr. So the OPT is methodologically fit, is falsification ready by definition. And the goal of the OPT is to provide a mathematical description of system and events consistent with their composition rules, allowing to evaluate their joint probability distribution depending on the graph of connections. So there are many OPTs. Quantum theory is an OPT. Classical theory is an OPT. There are many other theories, like, for example, real quantum theory, PR boxes, Popescu boxes, whatever. There are many theories that are in this category of theories, operational probabilistic theories. And the theory that we use for the problem of consciousness are the ones that describe the world, namely quantum theory and classical theory, that here are axiomatized in the most compact way. In quantum theory, we have systems. A is associated with Hilbert space HA, and the composition of system, which is associated with the tensor product of the corresponding Hilbert space, and transformation that are completely positive trace non-increasing maps, going from trace class operators on HA to trace class operator on HB. And the Born rule, which gives the probability of a transformation, which is a preparation, and it can be also a closed circuit if it goes from the trivial system I to another trivial system A, then it would be a closed circuit. So with otherwise, as in this case, is the probability of a preparation. It would provide the probability of a preparation. And the probability of preparation actually implies also the probability of all transformations that produce the preparation jointly. And quantum theory and classical theory instead, where I'm saying this is trivial, in place of this Hilbert space, you have the Cartesian product of n copies of R, and the composition corresponds again to the tensor, or if you want, the Cartesian product of RNA, RNB, and the transformation from the system A to the system B is described by Markov matrices. So you can regard classical theory as a restriction of quantum theory to a finite, fixed maximal set of jointly discriminable pure states. So you have a maximal set of jointly discriminable pure states. I'm sorry for my voice and for my problems connected. So I was saying that classical theory can be regarded as a restriction of quantum theory to a fixed maximal set of jointly discriminable pure states. So you have a jointly discriminable pure state and you don't make superposition. This gives a restriction of quantum theory. So this proves that since it's a restriction of quantum theory is more powerful than classical theory, differently from what Albert Einstein thought. So everything else we know about quantum theory are theorems starting from this very compact axiomatization. By the way, it's not just a compact axiomatization, it's also a better axiomatization of the von Neumann one, since the unitarity transformation, as I proved in a paper, is not falsifiable within quantum theory. So if I give you a transformation and I ask you to falsify if it's unitary, you cannot do that. There is no falsification test that falsifies that the transformation is unitary. So the axiomatization of von Neumann is actually not falsifiable. And I don't enter in all the details that if you know quantum theory, all these theorems are trivial. So we have seen the notion of system connecting events in an OPT and information theory as an OPT. And we had some words about the fact that the OPT is based on the strongest scientific method approach, and it is a device-independent black box approach, which is always the case when we do science, because we don't know what's going on at different scale. We are restricted to a particular scale. Now, we have to talk about qualia. Qualia are everything we are aware of. So thoughts are qualia, very complex composed qualia. Meaning is made with qualia. Feelings are qualia. Pain and pleasure are qualia. The color is a qualia. And so on. So I think everybody of you is familiar with the notion of qualia. Anyway, we can take as the notion of qualia the sound, the color, as an example. Qualia combine to make new qualia. Qualia are states of ourself as system, according to our point of view. So qualia are states of ourself as system is an hypothesis. So in this diagrammatic presentation of notions connected logically, I make self-evident notion red, hypothesis green, and theoretical notions as yellow, and experimental issues blue. So qualia are states of ourselves as systems. So awareness is private. There is no discussion about that. Everybody agrees that nobody can read my thoughts. But the hypothesis that we do here is stronger, is that it's not shareable even in principles. So there will be no technology that can make it shareable, So there is a theorem about all OPTs that says that if the information is not shareable, then is not classical, because the classical information is the only one which is shareable. So the awareness information cannot be classical. So the easiest choice is then to say, and this is the second hypothesis, the information is quantum. So we start with the easiest hypothesis of non-shareable information. And as a system, we are quantum. This is a consequence of our hypothesis. And qualia are necessarily quantum states, because qualia are states of ourselves as a system. So awareness is a private, this is self-evident. And the hypothesis is that privacy is a privacy in principle. So no information without disturbance theorem says that awareness cannot be classical information because this is shareable. And awareness so is non-classical operational probabilistic theories, like for example, quantum. And we, by hypothesis, select quantum case as the only one for the moment. So awareness is quantum. Sorry, I pressed the wrong button. Qualia are states of ourselves as systems. So we are the system that support information, and qualia are quantum states. Qualia are quantum states, and let's see some cases. For example, if you have a quantum superposition that creates new qualia in the case of the direction of a spin. So if I make the sum of up and down, I get right. I make the difference, I get left. So I build up the block ball by making superposition of two qualias that are up and down. And if I superimpose colors, I get new colors. So you can think this is not a superposition in the sense of quantum theory, it's a superposition in the terms of wave theory, but is the very strong analogous. So we add property to property, namely we add color to direction, and this is the main point of the talk. We get something completely new. So suppose we have an entangled state of up and red and plus down and green. You can think this as a red arrow up without the tensor product and the green arrow down. This cannot be, obviously, an arrow that is colored, because it would correspond to a superposition of arrows, tensor, a superposition of colors, not an entangled case. So you are creating something new. So if you make an up arrow tensor red with a down arrow tensor green, this will give you the superposition of a colored arrow, red arrow up, and a colored down arrow. And this cannot be an arrow anymore, because otherwise we are violating this inequality. And this is something strange, something new, a new kind of qualia. So by making entanglement of qualia, you produce new quantum qualia. This is something very strong, because this is a motivation to consider quantum theory as the case for a consciousness theory. We have different qualia that are exponentially growing with the number of systems. So we have considered, if we consider just entanglement between two states in a tensor product, we have 4 to the power n completely different qualia. But we can have entanglement of 3, 4, 5 qualia, and we have a huge number of possible qualia with few systems. So the possibility of creating so many possible qualias, if you think that the thought is a kind of structured qualia, in a sense, is the reason why we can motivate also quantum theory as a generator of thoughts. So entanglement and superposition generate high-level qualias, thoughts. This is the theoretical hypothesis. Now we have to define what is a non-tick state. Consider a coin with we know is head, and now we don't know what is the state, and we have an epistemic state, namely there is 1/2 probability that is head and 1/2 probability that is tail. So this is actually the way in which we distinguish an on-tick state, which is precisely known by an epistemic state, which is the true state, the on-tick state, and an epistemic state, which is just a mixture of two on-tick states. So on-tick states are pure states, and epistemic states are mixed states. In composite system is an on-tick state, pure is generally entangled. So consciousness states, namely qualia, are on-tick. So entanglement and superposition generate high-level qualias, namely what we call thoughts. And the system must be coherent, must be in a pure state. There is only one state for the coin. We don't know from outside what is the state of the coin. Then we have it in a mixture, but the state of the system, of the quantum system that we are, must be on-tick. It's not something that from outside is supposedly our state. And namely, this implies that the state of our consciousness is a quantum pure state by definition. So this is an hypothesis that is considered as self-evident. Now, the combination problem, most of you should know what is it, is a crucial point which is always used against panpsychism, which is the case of our theory. So the combination problem is the following. It is the most significant and pressing problem for the panpsychist. Stated generally, it is the problem of how precisely the fundamental conscious minds come to compose, constitute, or give rise to some further additional conscious mind, especially our own. So marginal states of entangled states are mixed. So if we compose two individuals into a single one, if it's a single individual really, then it is in a pure state, and this pure state generally is entangled. So if I consider the two components of the composite individuals, they will be in a marginal state, which is only epistemic. So this is not a conscious being. So if you want the high probability that the state is entangled, actually is almost everywhere entangled in the Hilbert space, makes the solution of the fact that if we put together in a single individual, two individuals, you don't get two individuals and at the same time one individual. It's only one individual because jointly the two may be entangled, and this is with high probability. So only factorized states are on-tick, and this corresponds to the case in which there is no interaction between the two, because otherwise they will prepare entangled states, and you have two individual, or if you want, one schizophrenic guy. Purity of the conscious on-tick state solves the combination problem through the individuation criteria that we pose, namely that awareness is individuated by coherence. So a system, composite systems with many subsystems, is coherent, then is aware. If it's not coherent because it's mixed, then it's an epistemic state, is not an aware state. So we have a criterion to define the personal identity, which is purity, and is the maximum, the minimum, actually not maximum, pure system. And if you want, we can say a la Descartes, in pure statu ergo sum. Now, what about the free will? The free will is quantum. Is really quantum. The lesson of non-locality is that quantum probability cannot be interpreted as a reading of a shared randomness. So if we have Alice and Bob playing with an entangled states, they see correlation that cannot be explained in terms of reading the same memory, the same copy, not reading two copies of the same content of the same memory. So there is not a shared randomness. So this means that there is no possibility of interpreting the lack of knowledge, of the fact that they don't know, is a lack of knowledge of persistent reality. So the quantum event, in this way, we can see that is actually cannot be seen as something pre-existing, but is really an act of creation. So a very genuine becoming. This is the right interpretation that comes from the lesson of non-locality of quantum theory. So in the Heraclitus sense. So free will is the quantum outcome. So we here make a small diagram which provides the whole ingredient of a theory, very simple. So we have a non-tick state, which is pure state. So with rank 1, omega is equal to 1. And then we have transformations that happens in the system that must be purity preserving, obviously probabilistic purity preserving. So in order to be purity preserving, they must be atomic, namely made by transformation with only one Krauss. So we have a state of our system, which is our consciousness at time t with for system AT. This is, by the way, a big system generally, and and this is the input system of a transformation that occur probabilistically, and which transformation occurs, which is denoted by this Ft, is the classical output, which corresponds to the free will. So which Krauss is the free will, and this transformation will depend generally on time and on a set of variables that are function of time. And you will get the output system, which is the state after the input coming from outside and the transformation due to the evolution. So the epistemic transformation instead would be the sum of all of possible outcome of the free will, and the epistemic transformation would be, by definition, deterministic. So the transformations are atomic. The special case of this is something which is in some very old draft of theories that says that the transformation is the von Neumann collapse in the mind, right? And but it is important to realize that quantum effects are very short-lived. So long-term memory cannot be quantum, must be classical. So the experience is quantum only for a short time buffer. long-term memory must be classical. This is very reasonable. Actually, many other possible theories, like for example, Penrose one, was criticized a lot because of quantumness as a very short time. And so the memory cannot be quantum. Long-term memory must be classical, and storing and recovering transforms quantum to classical back to quantum. So if I store quantum, transforming to classical, I lose some information, and then from classical to quantum, I still lose additional information. Actually, if you see yourself in special cases, as an example, you have a huge degradation of the experience. So this is why when we recall a memory, we don't have the experience of the actual moment, but we have a very degraded experience. So we even don't remember qualias, most qualias. And the optimal fidelity between the experience state and the recalled one for attention, where attention means that we are repeating the same experience many times in the quantum sense. So I have not one copy of the system supporting the information, but I have many systems supporting the same information because I concentrate on an input and I make 1, 2, 3 copies. Then the copy will increase the fidelity of the experience state with the one that is recalled. And this can be evaluated theoretically, and this is in a very simple formula. Depending on the dimension d of the supporting system, is m plus 1 divided by m plus d. The calculation is actually not trivial. It's pretty complicated, but the formula is very simple, where d is the dimension supporting information. And in principle, this is testable in cognitive experiments. So we have the possibility of checking something with a very simple formula. And if we have it, then we can even have an estimation of what is the dimension of the system. So actually, this is a dream. I'm not saying that this is easy feasible. But anyway, there is, in principle, a way to check the theory, for example, in this way. Now, this is not the only case. So I want you to remember, some of you knows that with my group in the last 10 years, we derived quantum field theory as information theory with very simple so-called quantum automata with the easiest information rule for the automata. So we have a criterion of simplicity in deriving the actual quantum field theory, which I think is very important and maybe has not been sufficiently recognized in the literature. But the fact that the easiest automata provides you Dirac is something which I think is astonishing. And now, so physics itself is information. This is what Feynman and Wheeler said. They believe strongly that physics is information processing. So you see now, if we put this together with the other thing that I said up to now, we recover a panpsychism in the sense that consciousness is physics, information processing, and information processing is physics. So we have panpsychism in the strongest sense. And I'm sorry for my voice and my problem. This is more or less what I wanted to say. And thank you very, very much for your attention. And I'm open to your question. I don't know how much time I spent.
Thank you, Mauro. Questions?
not the microphone. Very good. Thanks very much for the very interesting talk. And this is a very comprehensive system you have. I'm just interested in the point where Qualia came in. Qualia are quantum states. I mean, one way to put the question is, I mean, it looks like there's potentially the same gap between classical processes and Qualia as between quantum processes and Qualia. You tell a physical story about the evolution of the wave function, and there's still the usual gap to Qualia. So one way to put the question is, are you identifying the quantum states that you think are Qualia with, say, physical quantum states, some which are already there in our understanding of the, say, the physical wave function and so on, or are you taking Qualia to be an addition to that, like there are extra quantum states on top of that, or, I don't know, is it a more complex relation where the Qualia are serving as the intrinsic nature of the physical quantum states? I'm just trying to see how I mean, whether you're taking Qualia here as primitive elements and exactly how they're related to, physical quantum states.
So I don't know if I understood your question, but I believe that the answer, if I understood correctly, is that there is a one-to-one correspondence between Qualia and state of the information system that supports awareness. So the quantum states are in one-to-one correspondence with Qualia. So Qualia are quantum states of the systems that is supporting awareness, that is aware. So Qualia are quantum states of the aware system. This is exactly what, and I think is extremely powerful because you create Qualia with Qualia, and Qualia becomes so sophisticated when you have more than 3-4 systems that becomes so sophisticated that you get something complex as a thought. So by entangling many Qualia, like, just few, like 10 Qualias, in a different way, you get completely new Qualias that are structured and they can motivate the complexity of thoughts. So this is something that happens only with quantum theory, cannot happen with classical one.
Yeah,
so,
no, I totally understand. I understand the part about using Qualia to build up further on Qualia using entanglement. And actually there are a couple of nice papers trying to do things like that already, but I'm interested in the relation at the bottom level, where you said we said two things. You said there's a one-to-one correspondence between Qualia and physical quantum states. And then you said they're the same thing. Qualia are the physical quantum states. So those sound to me like two different claims. And insofar as we're making the second claim, I would worry about the explanatory gap, the hard problem, all over again, which is how does the standard physical quantum state actually give you Qualia? If you posit Qualia as fundamental additions, then the question is, how does that get to be identical to a physical quantum state?
So I would say that Qualia is the quantum state. I'm saying, if I consider that everything in my mind is a Qualia, so I'm using Qualia in a very large sense, namely a thought is a Qualia, is a composite Qualia. So everything is Qualia and the thought is a composite Qualia. There is nothing more than Qualia apart from, from the free will, which is a different concept, which I explain in a different way. Then everything is Qualia, everything is quantum state.
This sounds a little bit like the mind-brain identity theory, but with quantum states. So that, mental states are identical to quantum states. Interesting.
Okay, next question from Lucian.
Hi, Mauro.
As states, as structural states. So we have a composite system and the states are.
Hello? I think Mauro might be breaking up.
Mauro, are you there?
Mauro's gone.
Oh, he's
there you
back.
are, Mauro.
Can you hear us now?
Mauro, you're muted, but
I'm muted, sorry. I just got a drop in the internet, probably. So I was saying that Qualia and quantum states are in one-to-one correspondence for the aware system. And I believe that there is a conceptual difference, but the one-to-one correspondence, in a sense, identifies Qualia or thoughts more generally with quantum states of the aware system. And to be aware as a system of the system state is the essence of the whole experience. So you are a system, and the system, so this is why it is a panpsychism, because this is true for every system, for every quantum system. The system feels its own state. So we have something which does not change the physics, gives more interpretation to the same physical thing. So the state is not only just the state of a system, but the system can actually, by definition, the system since it supports the state, it feels the state. So the main point is that the system feels the state. It's not only a mechanical support of the state. This is the hypothesis. I don't know if I've been clear.
Thanks. Lucia?
I wanted to just ask you more about this. You had this argument from privacy of mental states, and then to quantum states as qualia, and you sort of using the no cloning theorem there. And I just wonder if it's this. I wonder if it really does what you want it to do. So it seems to me that there's two different kinds of things. Sort of privacy and no cloning seem to be different sorts of things. So in particular, for example, you might have a collection of qualia which just happen to be associated with orthogonal states. And you think that particular set of states are clonable, and yet we know from experience, so to speak, that we still have this kind of sense of privacy. So I mean, can you maybe say more about that connection? How strong do you think that argument is?
I'm not sure I understood your question. We know that quantum information is not shareable. Differently from classical information that is perfectly shareable, quantum information is not shareable. If I have I know the state of a system that I prepare, you don't know the state, and nobody knows the state. I have to tell you what is the state. Quantum information is not shareable. I cannot send one message encoded in superposition of states, and then 3 people can read it without one of them converting into classical before. So quantum information is a non-shareable information. Classical information is shareable information. This is a starting point. I'm saying that if we don't agree about that, then there is no discussion.
I agree with that, except that there are special cases where, if you
okay.
So okay. It seems that each distinct qualia is associated with distinct pure states.
No, but the special cases depends on the fact that you have some prior knowledge. Then it's different. You have more knowledge that comes from other reason. Then you can know things that otherwise would be forbidden by the quantum theory. Like, for example, you know the way the apparatus works. You know that yesterday you were very, very tired, and today you are sleeping. And so the fact that you have some additional information is something different. So I know that you are, for example, in this moment, very interested in my answer because you asked me. And although I cannot share your awareness, I know something about what you have in mind. Mm-hmm. But this comes from, this is the case in general, that you have more information coming from other sources. But if you are just yourself with your thoughts, I cannot know your thought. Okay. This is really not shareable information.
If we ever built an experiment, if we ever had conducted an experiment
sorry. But anyway, the fact that it's not shareable in principle is an axiom. Because one can say, no, that's not true. It's not shareable because we don't have the technology to do it. I believe that this is shareable in principle. Then it's quantum, because it cannot be classical. And it's not classical, but means that the only theory that we know is quantum. So,
in principle, you could teleport a quantum state from one person's brain to another. Would that be a way of at least transferring qualia, if not sharing?
Yeah, you have to entangle two individuals.
You have to, you need a source of entanglement. You don't need to.
The point is that once they are entangled, they make a joint state which is pure. This means that they are a new individual. Okay. So the combination problem actually is in this case is the case. I'm saying if you entangle me with you, we are no more two individuals. We are a new individual, and we are not you and me. We are only one if we are entangled.
Okay, thank you.
And there is no contradiction because we are not two individuals and at the same time one individual. We are one individual. Finish.
Cool.
Okay, we have time for one more question. So, Donald Hoffman.
Hi, Mauro.
Hi.
As you know, some physicists are now saying that quantum theory is not fundamental, and more physicists are saying that, such as Nima Arkani Hamed and his collaborators. So I'm wondering if physics finds out that quantum theory is not fundamental, that it's derivative from something far deeper, what will happen here?
I don't understand your question. So you suppose that quantum theory is not fundamental? This is the most fundamental. This is a very, very, I'm saying the sky is red. For me, the sky is blue. There is no discussion about that. Quantum theory is the most fundamental theory, full stop. So I don't answer to something that I believe is incorrect.
Well, are you familiar with the amplitude?
But the amplitude is something that is in the mind of few people. If you ask around in the world, nobody knows. So I don't consider theories that are not very well established, especially in considering a new field. I need to take very established starting point. Otherwise, if I take points that are not established, I make the even worse the situation. No, the situation even worse because nobody knows what is an amplitude. Nobody, and then I make what? A theory which I don't know, using a theory which people don't know and maybe even wrong because it's too recent. So methodological, I think, is not a good thing. I told you many times. This is my opinion, obviously.
But since that went quickly, maybe I can throw in a short question before we finish. You mentioned the Hameroff-Penrose-Walker model, and it faces this problem of decoherence in the brain. And you talked about how your model would avoid it. And you said, well, memory will be classical. And then you said experience, on the other hand, will be quantum. And I think you said for just a short-term buffer. And I just didn't really understand that claim. And I think generally I don't quite understand how you get around this decoherence problem, especially since you were representing qualia as these superpositions that look like they will decohere pretty quickly in the brain. So could you just say a little bit how you avoid that problem?
No, I don't have this problem because what I see now, I see colors. I have a feeling of your voice. I I see space around me, I see objects. This is something very, very short-lived. So I just change the position of my head, and everything is different. So actually, we are living as an experience, the experience is defined for a very short time and is changing all the time.
I see. So we have a constant
memory. When we memorize, we memorize extremely little. And I'm saying that the degradation is not just we memorize a few quantum things. We transform the full quantum information into classical one, which is huge detrimental. So the memory is very, very poor. In fact, if you think about actually our memory compared to reality is very, very poor. Is the same difference between quantum and classical. Classical is nothing compared to quantum. And then I have even worse the situation. I have to reconvert classical to quantum to have a remembering of my experience, to recover my experience. So the recover of the past is something very, very weak. The fidelity is extremely small.
So we have this constant stream of experience, and it's sort of composed out of these like little flickers out of these short-term partial experiences, and then we only remember a certain amount of that. Is that roughly? Yeah.
Okay. So actually, the experience is something which lasts few seconds, or maybe less than 1 second. I don't know. It's changing continuously. And I memorize very little of what I see, very little. If you think about, so we need to find a way to quantify these things. This is not my problem. We need cognitive scientists to do that, to quantify how much information we have in recovering experiences from the past. And this would be actually very interesting, and I think it can be even quantified. But we need people like, not psychologists, I don't, a cognitive scientist, to do, to build up some numbers about just what we can recover of them. We have to find a way to quantify the amount of information that is in a thought, in a recalling. This kind of thing has never been done in my knowledge. I have read a few books, part of reading the books of David Chalmers that I enjoy a lot, and it's been my teacher. I read books from neurologists and other things like that. I couldn't find anything interesting in these books.